So here's the thing. Developing a new drug and getting it to you can take a long time. When we have to work out the cause of a condition, for example with multiple sclerosis or heart disease, developing a new drug takes significant trial and error and lots of money. Which is why we only have drugs for a small proportion of diseases. But you could change all this. You could help discover new, cheaper drugs for currently untreatable diseases. It's all about medical crowdsourcing. However, researchers aren't asking you to donate your money, they're asking you to donate something more personal. First though, some drug dev history. Many of the first medicines were discovered by chance. Natural philosophers then took these and identified the active chemicals inside. And pharmaceutical companies then turned those into drugs. The thing is, for a long time, we didn't know why those drugs worked, until scientists figured out that disease happens when the molecular machines that keep your body going, your proteins, start misbehaving. Drugs treat disease by targeting those disruptive proteins. Researchers realised that if they can identify which malfunctioning proteins cause a specific disease, they can then try to find or develop a drug that stops those proteins acting up, and that will prevent the disease. It's a great plan, but it's a slow process. So far, they've only identified these therapeutic targets for a small proportion of diseases. However, this is where you can help. Researchers are now turning their attention to DNA, to the genetic instruction manual that tells our bodies how to make our proteins. They want to know which small changes in someone's genome can lead to the production of those dodgy proteins that cause a disease. The thing is, that's a big job. DNA is huge, and each disease is likely to have hundreds, possibly thousands of proteins involved. But if they have lots of people's genomes, they can compare them and spot patterns. They can look at multiple people suffering from the same currently untreatable disease, find any small genetic changes they share, identify the faulty proteins they code for, and there you go. Those are brand new therapeutic targets for a currently untreatable disease. Now the researchers have 3 options. 1. Has one of those new target proteins been previously linked to a different disease that is treatable? If so, the drug for that disease may target this protein and work for this disease too. To find out, start a clinical trial. 2. If not, has one of those new target proteins been previously linked to a different disease that had a promising drug that didn't ultimately work? If so, its promise may have come from successfully targeting this protein, and it may work for this disease. Start a clinical trial to find out. 3. If this is a brand new protein target never identified before for any disease, could they design a new drug to affect it? This involves AI, machine learning, and some very cool chemistry, and a lot of time, effort, and cost too. Researchers are excited about all this because they think 1 in 5 of the proteins in your body either have or are likely to have a drug that will bind to them. And as any common disease is likely to have hundreds, possibly thousands of proteins involved, they're hopeful they'll be able to identify a few of those proteins they've already got a drug for. But this all relies on finding those new therapeutic targets, and that's why they need you. Well, your data, both your genetic data and your health history data, so they can compare the genomes of people with similar conditions. So would you give your data for research? There are 2 questions you may have. Who will have access to my data, and what could they do with it? One group is healthcare providers who are starting to consider using genetic analysis to give patients more personal care. Another group is private consumer genetic testing companies. Some have already sold genetic data on to pharmaceutical companies for profit, but that was with their customers' consent. However, it raises another question. If your data goes towards making new drugs, should pharmaceutical companies recognise that contribution and offer drugs more cheaply? Your best bet is to research the organisations who are asking for your data, to find out what they will do with it and how they will protect it. We'll each have our own take on this, but what is clear is genomics could be a powerful tool to cut the current time and cost it takes to develop new drugs for currently untreatable diseases. So, what do you think?